Nanotyrannus, a distinct Tyrannosaur species, not a teenage T-Rex. Nanotyrannus, a distinct Tyrannosaur species, not a teenage T-Rex. For decades, paleontologists have debated whether the fossil of a small, fierce theropod dinosaur belonged to a young Tyrannosaurus rex or represented a separate species. Recent analysis provides a definitive answer. Nanotyrannus can stand on its own. A newly examined fossil demonstrates that the tiny Tyrannosaur isn't simply a juvenile T-Rex, scientists report in Nature. The fossil in question is part of a celebrated discovery known as the dueling dinosaurs, a remarkably preserved pair of dinosaurs, a small Tyrannosaur and a horned ceratopsian, entombed together in Montana's 67-million-year-old Hell Creek Formation. This fossil has become a crucial, missing link in the debate around Nanotyrannus. This analysis reveals that the dueling dinosaur Tyrannosaur is the first identified adult specimen of Nanotyrannus lancensis. A lingering identity mystery, the mystery surrounding Nanotyrannus began in 1942 with the discovery of a small, sharp-toothed dinosaur skull initially identified as Gorgosaurus. However, in 1988, scientists reinterpreted it as a new type of Tyrannosaur, naming it Nanotyrannus lancensis. This classification has been challenged over the years, with some arguing that the skull belonged to a juvenile T-Rex, citing similarities in features. Confirming adult status and distinct features, a team led by paleontologists Lindsay Zano, North Carolina State University, and James Napoli, Stony Brook University, now firmly establishes N. lancensis as an adult species. The fossil measures approximately 6 meters in length, considerably smaller than the maximum 14-meter size of adult T-Rex. An analysis of growth rings in its leg and arm bones confirms that it was skeletically mature. Crucially, the new analysis also includes the first preserved tail and arm bones of a Nanotyrannus. These bones exhibit notable differences from T-Rex. The N. lancensis tail had only 35 vertebrae, compared to the approximately 40 found in T-Rex. Perhaps most strikingly, the Nanotyrannus arm is already larger than the arm of a T-Rex. Additional distinguishing characteristics lie in the skull's cranial nerves, the structure of sinuses, and the respiratory system, features that remain relatively constant throughout an animal's lifespan. Revisiting, Jane, and introducing N. lethius, the team also re-examined the fossil nicknamed Jane, previously assumed to be a juvenile T-Rex. By comparing Jane's anatomical features with those of the dueling dinos fossil and over 100 other Tyrannosaur specimens, they concluded that Jane was actually a young Nanotyrannus. Furthermore, they proposed that Jane represents a new, slightly larger species of Nanotyrannus, which they have named N. lethius. The name refers to the river Lethe of Greek mythology, said to induce forgetfulness, hinting at the idea that Jane's true identity has been overlooked for decades. Ecological niches and implications for T-Rex research. The discovery suggests that Nanotyrannus and Tyrannosaurus may have lived side by side at the end of the dinosaur era, occupying distinct ecological niches within the Hell Creek region. While T-Rex was a bulky, heavily built predator with a massive head and powerful bite, Nanotyrannus was smaller, slender, faster, and possessed larger predatory arms. This finding adds to evidence demonstrating the diversity of dinosaurs right up to the Cretaceous-Paleogene extinction event. Thomas Holtz, a paleontologist at the University of Maryland, notes that this finding reinforces the commonality of multiple Tyrannosaur species within dinosaur communities, making the Hell Creek Formation less of an anomaly. A wrench in T-Rex understanding Zano emphasizes that this discovery has far-reaching implications, potentially requiring researchers to reevaluate decades of research on T-Rex, as much of it has been based on data derived from both species. Furthermore, she raises the intriguing question: if Nanotyrannus is confirmed, what does a true teenage T-Rex actually look like? A potential answer may lie in a fossil currently being prepared at the Denver Museum of Nature and Amp. Science, believed to represent a true adolescent T-Rex. The discovery of Nanotyrannus as a distinct adult species necessitates a re-examination of established research and raises fascinating questions about the life history and evolutionary relationships within the Tyrannosaur lineage. In conclusion, the newly confirmed existence of Nanotyrannus lancensis as an adult species fundamentally alters our understanding of Tyrannosaur diversity at the end of the dinosaur era, forcing a critical review of existing research and presenting exciting opportunities for future discoveries.